Thank you very much, and thank you for the introduction, and thanks for joining me for this Gradle talk. My name is Xavier Gouchet. I'm a French software engineer at Datadog, and you can find me online on Twitter, GitHub, and whatever with my handle over here. If you don't know who Datadog is an online monitoring system, the service that allows you to track status, logs, and performance metrics over all your application and organizations. You can look at us over the internet. On a side note, we're hiring, so if you like what you see and if you want to join us, you can look at our website where we have all our career opportunities, or you can talk to me afterwards. So, first of all, we're going to start with a Gradle introduction. Just a show of hand, who here is using Gradle as their build system? Okay, good. You're in the right room. So Gradle, first of all, what is Gradle? So we use it because it's the default on Android. The question is what it is exactly. And first of all, the main thing you have to know about Gradle is that it's general purpose and language agnostic. So even though it's mainly used in the Java and Android world, and Kotlin too, it's not meant especially for Java or Android or Kotlin or whatever. It can be used to build whatever you want. So you can build C++, you can generate PDF files, you can use it for whatever purpose you want, and you can use it, of course, with Java, Kotlin, Groovy, Python, or any language you want. Second thing is that at its core, it's a dependency management system. And this is the main focus in terms of performances. And this is used, of course, for the libraries dependencies. So when you say, OK, I want to use Jetpack, Android X, or whatever, it can use that to know what dependencies that dependency is using and resolve all of that. But also in the task dependencies, so it knows that building an Android app relies on first compiling the Java classes and Kotlin classes and relies on a lot of other stuff. So this is used to build something. So, sorry. Now there is the Gradle algorithm, which is basically what happens when you invoke a Gradle command. And the first thing is the initialization that almost no one talks about, which is first it launches a JVM or reuses an existing one if you have a daemon, and it's going to analyze your working directory. So it's going to basically look at what are the modules in there, and it's going to create the project objects. And then it's going to compile the build source module. And we're going to spend a lot of time on this one, so bear with me. Second thing is going to execute all the build.gradle scripts in your project. And I mean not just read them, but execute them. So everything in there is going to be executed even if you're only using a single task in one of your module. While it executes that, it's going to create and configure the tasks, and it's going to resolve all the dependencies. And finally, it's going to execute the tasks you asked, and of course, the tasks they depend on. So now I mentioned the build source folder. We're going to dig into what this is. Do anyone here knows about it already? OK, so this might sound familiar, but basically the idea of the build source folder is it's this magic thing that gives you a lot of power over your Gradle configuration. So let's look at a sample project. You're going to see something very familiar. So you have your project with the root build.gradle and settings.gradle. You mostly already know about that. You have your app folder with your source folder, your build.gradle, and you have your build source folder. So it will look like any other module that you can have in your project, except that the name is reserved. It's a special name. Be careful, it is a capital S. I struggled for a couple of hours the first time because I used a lowercase s and it doesn't work. And what this is, it's a special folder that you can use to enhance all your Gradle scripts. How does it work? It works by being, it works like any module in the project. It means that it has a source folder, it has a build.gradle, and you can compile anything into it. And it is compiled and tested before any Gradle task. If you remember in my first slides, I said the initialization part is building and testing the build source module. So before it even looks at your build.gradle script, it's first going to compile and build this module. And so you can use it in Groovy, Java, and Kotlin, anything that can generate something, some Java bytecode. My example here are going to be written in Kotlin because it's simpler, but of course, if you want to write it with Java, it works the same way. And any public class or methods that you create in this module is going to be available from your build.gradle scripts. So what can you use it for? You can use it, so this is some example we're going to see. You can use it for the better dependency management. You can create helper classes or methods. You can, of course, create some plugin configuration and write your own plugin that are going to be versioned with the project, which means that you can create your own plugin with your own code specific to your project, and it's going to be inside the same Git repository, inside the same project, so you can use it, of course, in your CI servers. Note that a single change in the build source module can cause the whole project to become out of date. Because if you change this module, it means that you change the way all the build.gradle scripts are going to be behaving. So usually you don't change it that much, but know that if you make a change in there, it's going to make all your tasks become out of date. So now let's look at some scripts. First thing I mentioned was dependency management. The idea is here to write once and use everywhere, especially if you have lots of modules in your project. So we're used to having something like that. You have your dependencies block when you say you have the implementation of Kotlin and Android X and RxJava and OKHTTP and everything. The idea here is in your build source module to create an object, which is basically a singleton dependencies, where you're going to say, these are my versions, and you can name them. So I have the version number for Android X, for everything else. And then you can create constant values that are going to be referring to your libraries. So for instance, you can say, OK, my Kotlin library, this is this name, and you just inject in it using the Kotlin syntax the actual version you're going to be using. You can also create an array of dependencies and say, OK, I want to import to have an implementation of Android X, and you can actually put all your Android X implementation in this array, and we're using the JVM field here to make sure that Groovy is going to understand it in your build.gradle script. And then you can just say this. So you're going to say, OK, my implementation is now dependencies.libraries.kotlin and dependencies.libraries.androidx, which is fairly nice because now you can name them. So if you're depending on some GitHub library that has an obscure name, you can name it correctly. And also, because this is compile, you're going to have some completion when you're typing this. So if you want to know, oh, I want to import libraries, you can just start, say, dependencies.libraries. And then Android Studio or IntelliJ is going to offer you the list of libraries you already know. So very, very nice when you have lots of modules. And of course, it works with implementation, with compile, API, test implementation, and all your flavors the same way you're used to do. Then you can also use the build source folder to centralize all your configurations. So for instance, if you have detect in your project, you have this kind of block resting in your build.gradle file where you're setting up the plugin. Well, you can actually create an extension function on the project object and say, oh, actually, when I want to say detect config, this is going to do kind of the same thing. So you're going to find your extension. You're going to configure it, so it's basically the same thing written before. You can also reorder the task and say, well, when I run the task check, I want to run detect before that. And in the end, in your build.gradle file, you just have to say detect config, and you have all of that here, which means that your build.gradle file is becoming easier to read and thus to maintain. So then you can also create utilities. We all know the how we use version code and version name in Android, and you have two different fields. And what is sometimes bad about this is that sometimes you are going to change one and forget to change the other. And so you need to make sure that they are in sync. And usually in most of my projects, I try to make them in a way that it's easy to know that they're in sync. So what I can do is create a data class in my build source folder that's going to say, okay, I actually have an object with a major, minor, and hotfix. And I'm going to have properties that just generate the name and the code directly. And of course, you can improve that a lot. But then if you have this, and you say my name is derived from this thing there, you can create a constant value here in the build source folder and say, okay, this is my version. And you just say this is the version, and you don't have to remember how you change the name and the code. And it's going to be all done for you in your build.gradle file. So then you can create plugins. So creating plugins, or we all use plugins a lot in our projects. Plugins have a lot of utilities. So you can create tasks. So task is basically a single step in all your build system. So it can be, reading a file and doing some analysis on it, or it can be generating something from a source JSON, or it can be all you want. You can have extensions. So extensions is what enables you to enhance the script you're writing by offering new DSLs to write things. Like the Android block is something that's not in Gradle. It's actually the Android plugin that allows you to write Android with the curly brackets and configure the Android plugin itself. And you can also, the plugin can automatically configure everything in your project and tasks and dependencies. So we're going to look at a concrete example because I don't want to do just a hello world. So we're going to look at something that I had to deal with, which is sharing the localization strings between the platforms. So we had a server with a source of all the strings we had and all the translations in all of the languages. And we had an API to download the strings.xml files. And the idea was to be able to automatically download it and not have to do it by hand. So the first thing to do is to create the task, which is what's going to be doing the real work. So this is basically what it's going to look like. So first of all, you create a class that needs to be open. That's named here getStringsTask, and it inherits from the default task. So the default task doesn't do anything. It's just a basic Gradle task. Then we're going to have some configuration properties. So we can have a list of strings that are going to say which language I want to download. The root is going to be the root folder in which I'm going to place my strings.xml. And the base URL is going to be the URL I'm going to be targeting to download the string files. And here I just set it to the local host, but you can change it afterwards. And when you're writing a task, there is just this main method. You can name it whatever you want, but you have to have the annotation task action on it to say, this is what my tasks do. And here it's pseudocode, but basically for every language I have in my list, I'm going to download from my URL. So I construct the URL, I construct the local file path, and I'm just going to download it from here to there and have it in my folder. And so in my build.gradle script, I only have a task object, so I just import it, and I can create the task and configure it here and say, okay, my language is going to be English and French. The root folder is going to be my project directory /source/main. And my base URL is going to be example.org/locals or whatever, wherever your strings.xml files are online. So this is fine. Problem is you still have some things that you have to put by hand and they won't change, like this here. For any project, it's going to be automatically the project dir/source/main, and you still have to create the task yourself. So we're going to use a plugin to actually do that for us. So we're going to use an extension and a plugin. So the custom extension is, as I said, something to enhance the way you write your Gradle scripts. So we just create a simple plain object that's going to have our language and base URL. So it's the same properties we had before. Doesn't have to extend anything. It just needs to be open because Gradle does some trick with it in the background. And then we're going to update our task. So the update is mainly we're going to depend on having an instance of this extension here, and we're going to use it to configure the way we fetch the URL and the way we iterate over the languages. And then we can create a plugin. So a plugin, to create it, you just extend the default plugin class that simply says, okay, I can do something with a project, which has a single method you need to override, which is apply. And on this, the first thing we're going to do is going to say, okay, we're going to create a new extension. So this is the name of my extension. So I just picked get strings. This is going to be the implementation of my extension. And just doing that, it's going to add this extension. So you know you can use it in your build script when you apply the plugin. And I just keep it the instance here. Then I'm going to create the task automatically. So again, I'm just using get strings, but you don't have to use the same name. You can have different names if you want to. And again, when you say create, you just say which name it is and what's the implementation. And then I'm going to configure it. The first thing I said, yes, we can configure automatically where the root folder is. So I'm just going to take the project dir path and append /source/main. And I'm going to link the extension I created before with the task here. And so now in my build.gradle file, I can just apply my plugin here. And now I have this block that is legal in my build.gradle file because I created the extension. And so I can just say, okay, get strings, this is the configuration of my get strings plugin. And I can, again, set the languages, set the base URL, and I don't have to specify the root path anymore. So why you want to use a plugin or plus an extensions? It means that the extension is easier to configure because now you have your own name named block to configure it. The plugin can fill some properties automatically, like the root path, like we did, and you can even generate tasks per variant. So if you want to do something different in debug or release, you can do that. Or if you want to do something different between the dev and prod variants and flavors, you can do that. And of course, you can manipulate the graph. So you can say, actually, the task I created is going to be a dependency of another task. And so this is something that's fairly simple to do. So now that we've done that, we can go a little bit further and explore what we can do with this plugin. First thing I mentioned is ordering the task. So here in my plugin class, after I created the task and configured it, I can call this. So project.afterEvaluate just waits for all the plugins to be applied, meaning that we know that when we're inside this block, the Android plugin has been applied and it has created all the Android-related tasks on your project. And so then I'm going to just find all the tasks that has the generate_res_values class, which is, so this task here is the task that's going to read everything in your res folder, and it's going to generate the r.id and r.string and r.layout that you can use in the code. And because we're downloading strings, we want this download to happen before we generate this r.string classes. So we're going to say, when I find such a class, I'm going to say that it depends on my task that downloads the strings. So now every time you're going to compile your Android project, it's going to download the strings, and then your r.string values are going to be using those. So we're going to have a side note here on the task order. That is, there are two ways to work with task order in Gradle. There are the strict way and loose way. The strict way, I think most of you may have seen the depends on, and it's fairly straightforward. When you say A depends on B, it means that if you ask for the task A to compile, it's first going to run task B. always. And c.finalized by b, it's the other way around. When you run c, it's always going to be followed by running b. The other one is the loose dependency, and this one is a bit trickier. So first, for the must run after, it means that if both tasks are in your list of tasks, then they're going to be ordered with D running after B. But if you just go Gradle D, like I did here, well, it won't run Gradle B. It's just if you say, I want to run Gradle D and B, then it's going to make sure that D runs after B. The should run after is a bit different. So likewise, if you just run Gradle E, it's only it's going to only run the task E. But if you want to both of them, it's going to run B before E. In some cases, when you have multiple processors and tasks run in parallel, it might happen that it's not going to honor this preference. And also, if you have this kind of dependency cycle where you say that actually B depends on A and A depends on E, you can't have E running both after B and before B. So it's just going to silently follow these strict dependencies and ignore this one. So anyway, now we have our plugin and the tasks are ordered. We want to have a better integration because we still have some things to do. And so the first thing you can do is alias the plugin. So in the build source configuration file, you can actually use this plugin to say, okay, I have my getStrings plugin class, and I want to alias it as getStrings. And so what this means is this will, whenever the project is created, is compiled, and whenever it compiles the build source module, it's going to generate a manifest that's going to be understood by Gradle, and that's going to say, okay, when you actually say plugin getStrings, it's actually going to use this class as an implementation, meaning that instead of using import getStrings plugin and then applying it, you can just say, okay, I'm applying the plugin named getStrings. Another thing that you can do is create the tasks group and description. So by default, all your tasks are going to be in the other group and with an empty description. But in your object, you can set this property, group and description, which means that when you list the tasks, or either in the console or in Android Studio's Gradle panel, you're going to see the group that you defined, and all your custom tasks are going to be in there and easy to find. Then you can use the Gradle cache to avoid all the unnecessary work. That is, for now, the plugin that we created, it's going to download the strings every time we compile the project. And I don't know about you, but when I'm working on an app, I can build the app like 100 times a day. So I don't want to download the same files over and over and over again. So you can use inputs and outputs in your task to define how Gradle can know if your task needs to be run again. So the add input or add input files or add input list, there are lots of different input annotations that you can use. Basically, what it means is it's going to say, call this method and treat the results as an input for my task. So here we have two inputs. We have the list of languages, and we have the base URL on which we're targeting. And so this means that if you change the language list, or if you change the URL for Gradle, it's going to mean, oh, my inputs have changed, so I need to rerun this task. And unless you change those, it won't rerun it again. Another thing that you can define are the outputs. So yeah, I'm going to define the outputs file. So I'm going to generate the path to all my outputs file. And so this is going to generate a list of files depending on my list of languages. And so this annotation says to Gradle, well, call these methods and treat the results as outputs. And because it's output files, it's first going to look at if the list of path changes, but also if all these files have changed themselves. So he's going to look at the file size and file hash, which is going to help him know, help it know if your outputs have changed. So if, for instance, you did a clean or you deleted the strings folder, well, in this case, the outputs files are going to be missing, and it's going to rerun the task again. But then, if we only look at the configuration, so language and URL and the output files, if you never update them, if you never update the config, if you never delete the string files, it's never going to update anymore. So to fix this, I made this trick. I created a fake input that's not a real input of my task. But basically, I said, OK, actually, the input is going to be the date of today. And so the date is only going to change one time per day, of course. And so what this means is you're going to update your strings.xml file at least once a day. You could do something a bit smarter or a bit more often, but basically this is a good way to do this regularly, but not every time you run your project. Going further with this, you have incremental tasks, which is also a way to avoid unnecessary work. And this means that you can say, oh, actually, only part of the inputs changed, so I only don't have to do the whole task and just part of it. So for instance, you create, in your task action, you add an incremental task input here, object, that's going to be telling you if your inputs change incrementally or not. So if is incremental, basically if incremental if incremental change is supported in your Gradle version, it's going to say you're going to be in this loop here, in this block here, and so you can list the out-of-date inputs and the removed inputs. So for instance, you could say, oh, basically if the language list changed, then I'm only going to download the languages that are missing and don't have to download the other list. And if some inputs were removed, like if some languages were removed, I just delete the local strings.xml that's related to it. And if it's not supported, of course, you can just resume your original task action. Then comes the matter of testing the plugin, because test matters. And I sure hope you all test your code, of course. So first of all, I mentioned that earlier, but the build source module is tested on each build. On each build, unless it didn't change, so it's cached. But whenever you do a change on the build source folder, or whenever you do a cold build of your app, the build source folder is going to be built and tested, which means that you need to be sure that your tests are short. So in many CI online nowadays, you are going to generate a VM or a container, and you're going to build your project from scratch. So if your build source tests take a long time, this is going to increase your build time on your CI server. So what can you do to test your Gradle plugin? Well, first of all, you're going to look at the plugin itself, which is test the actions that the plugin do, which is create the task, create the extensions, link them, and configure them. Then you can take a look at what the task does itself. And so this can be trickier because we're in a unit test, but you can delegate to another class the actual work. Like I did in my example, I delegated to a downloader that would actually do the real work, and the task is just passing around the inputs and outputs. And of course, you can do some integration tests where you create a dummy project and apply your plugin on this. You can go even further by creating a DSL. So creating a DSL is basically a trick to go deeper in your extension and be allowed to create variants. So for instance, you can say, oh, actually, I don't want to download all my languages when I build some variants. So in debug, I only want to download the English language. When I run the free version, I want to download the English and French version. And you can have, of course, all the flavors, all the variants combination that you could have in Android. So in full release, and only in full release, I want to have English, French, and Spanish. So Actually, I have a GitHub sample project repository. I'm going to give you the link, and you have the actual implementation of how you would do this. So you can see that. And of course, the DSL can go as deep as you need. It just becomes trickier to go further, but you can go as deep as you want. Then you can, of course, generate stuff, which is what most tasks do anyway. So there are tasks that look at your Java code and generate bytecode, or Kotlin and generate bytecode, or all those stuffs. You can generate files, like you can generate your Android manifest, or you can generate some source code. There are two very good libraries named Java Poet and Kotlin Poet that allows you to generate valid Java and Kotlin code. So if you want to do that, generate class files, this is very, very nice to use. So you can take a look at that. You can generate your resources, so the strings as we did in our example, but you can also generate drawables, layouts, navgraph, or whatever you want. And you can generate, of course, assets. A side note, if you're generating something, make sure that your generator task is executed at the right moment. So much like we did in our getStrings task, we made sure that it was generated before the Android build pipeline needed to look at those strings files. So, wrapping up, if you have to take away one thing, the build source folder is always built and tested, and everything in it is going to be available in your build.gradle file. A single change in the build source is going to invalidate all tasks. So a single change means the build source is going to be rebuilt and retested, and all your tasks are going to lose their caches. And finally, if you create your plugins and you use it on your own project and you think that it can benefit others, you can always extract your plugin code and put it in a separate project, and you don't have to change a single line of code and just publish it that way. One last note, your build scripts are still code. And so you need to keep them as clean and maintainable and understandable as your production code. I've seen projects where the build.gradle script was 500 lines long with no comments and a lot of stuff that no one really knew how to read and how to change. And most of it was just copy-pasted from Stack Overflow. So make sure that you understand what's in your build.gradle files. If it's too long, you can divide it, so you can use all the tricks we've seen here. The advantage of using the build source folder is that all your code is going to be compiled, so you're going to have completion, you're going to have the compiler that's going to check everything you do. And so you need to make sure that it's easy to read and easy to maintain. So you can get those slides online. You can get the sample projects on my GitHub account. I'm going to post all of those links on Twitter and on the Mobile Era Slack. And I thank you all for your attention. If you have any question, thank you.